Who has written a Python script before? Hands up, please. Great. And who actively uses Python as their primary programming language? Cool. And who has used Vyper? Okay, that's already a lot more than anybody ever before, so thank you so much. And really appreciate it. And yeah, this is the reason I do it, because people want to work in Python, and we need alternatives, and we need, I always go explain it this way. If you go look at the history of Unix, started like in the 70s and coincided with the invention of the programming language C. You had this like massive branch out, like 500, so basically you need to experiment, and then eventually you'll converge on solutions. And that's why it's so important that we also experiment in writing in different smart contract languages. And yeah, Vyper is the Python-like one. And yes, we have a logo now. I'm quite happy with that. We did a bounty, and it came out really nice. It fits in nicely, so we have a logo now. Basically, just a short history on Vyper. I think about a year ago, basically Serpent was marked as unsafe, but this was not really Serpent's fault, because Serpent was closer to LLL than any other language. You could address memory very directly, and there was basically a need for a higher level. And Solidity, looking like C, is kind of like an interim layer, but we needed something higher, something more protective, something more friendly and more Python-like. And this is how Vyper was started. I wasn't there for the inception. I came later, but yeah. So the big thing is like we're programming money, and as we know, there's like a lot of mistakes we make, and we try and learn from them. But then we can also say that you, in your everyday life, you like drive a car, and you rely on certain safety features, and this is why it's important that we have other languages that you don't need to know the underlying memory or the underlying, and a good example is like the overflow checks, right? So you don't need to know that an integer will overflow, thereby causing a massive flaw in your contract to write a contract. You need these extra padded safety features, and this is what Vyper tries to provide. So I'm just going to go through some of the decisions, and this was like you could say it's like the tail of like the manifest of Vyper, and some of the design decisions that were made. When we make a decision, we have, and this is really nice, and I can recommend everybody to join, is like, we make a proposal, and then like, one of the first things is like, we say that the reader must be able to audit it first before. So it's like, if it shouldn't be a convenience function. If it's a choice between a convenience function and auditability should take priority. So that's the first. In direct comparison to Solidity, we don't have modifiers. We will revisit this in a later version, perhaps, in something like what my idea was like a built-in standard one, because there are some scenarios where you might want to say, okay, there's this one use case that everybody ends up using, but at this stage we don't have modifiers. Instead, we just have assert statements. And you might think, oh, that's horrible, but it's not so bad, because a lot of the assert statements you see in your Solidity contracts are anyway things that do like overflow checking. So like immediately we have less asserts. So instead you just do one assert statement, and it's only one, like you have that one check in your function, you know, like, is this a zero address? So, then another very interesting thing, and this gets people that have used Solidity before, is we don't have any infinite data structures. So you can't just keep adding to an array. You have to have fixed sizes. So everything is a fixed size. Even the byte strings have like an upper limit. So it looks like bytes, and then you'll say, okay, you have 1K. You can, the moment it overflows, like you can only occupy that amount of space. So this allows you to kind of predict what is the maximum amount of gas you'll need actually run a function, because you know its own fixed size. But more importantly, it prevents a gas limiting attack, which is like a technique where you can lock up funds, because you know like the one block processes every 30 seconds, and you know like the miner set the current gas limit to this much, and then you like, okay, let's say just keep adding a claim on an identical to contract into an array. But then you know having to iterate through this array will cost you so much gas, and you can kind of lock up a contract, and it's unusable. But if you have like a limit, you say, okay, I have only 10 claims that can ever occupy the space, it won't allow you to go further, and thereby we know, okay, it's constrained within what the block limit is, the block gas limit that the miner sets. So that's why we have finite data structures and finite length loops. So you can't say for this in this. Well, you can say for in, because the array will always be fixed. But if you do a for loop, you'll always have to specify a specific limit that you have to iterate through. Then we use the Python decorators, public and private, to specify, and it's not a choice. Solidity has also adopted this recently, I believe. So you have to say, is this a public function or is this a private function? And you have to specify both. So it's quite interesting. Like, number one, we don't have this, it wouldn't have been such a big problem in Vyper, again, because we removed inheritance. So, but still, just for safety's sake, just for that explicitness, what type of function is this? You shouldn't make assumptions. The reader doesn't necessarily immediately realize, is this public, is this private? What's the default of the language? And that's one of the explicit things that we prioritize, right? Oh yeah, so the next bullet is we try as much as possible to prevent any type of recursion. There is obviously, like, I always say this, like, you can't fully prevent it because you could chain it, but this does, to a certain degree, like, it makes it a lot more difficult to do so. Yeah, that's this one. Our decimal type is fixed, decimal fixed point. So, like, for a financial system, it makes sense. And we used to call this type decimal. On IBI, it's now fixed one. I can't remember, but we have like a nice. I think it's fixed 186 by 10. Then you know. Yeah, there we go. Yeah, we had some trouble with that, but that's not supported on the ABI. So I have a nice example there. It's like if you take thirds and you plus them in Python, for instance, you end up with these strange numbers, and in JavaScript as well, you'll have like 0,999 repeating, and you're like, well, that doesn't make any sense. So using a decimal type actually prevents that. So we have basically, it came to this where we have two integer types and a decimal type. We have a signed integer int128 and we have a uint256. And all of our data types have some sort of overflow protection, either by always checking the upper bounds, or we use like the safe math equivalent, always compiling. It doesn't make sense to us to like, let's include the one file that like saves your contract. That doesn't make sense. The next bullet is also very obvious. We don't allow inline assembly. Like, there's like just too much that could potentially go wrong, allowing someone to alter the inner states of the EVM at any point in time. Also, like, when you start using libraries and reuse and so forth, if you have like that one M load somewhere, it could completely just cache up all your funds. And then this is a very interesting topic, is the no inheritance. Not because, it's mostly because what do you do as an alternative to reuse? And I'll come with an example later where we can always interface with external contracts, and the idea is that, anyway, for this iteration is like, keep it simple, keep it straightforward, keep it minimalist, and therefore we have the only case where we use something that looks like a Python class is to specify the interface to another contract, and in that way you can reuse, but it's never a sense of like I inherit all these functions and apply them. So it's a lot more like composition. Right. So I thought like with people that have actually written Python and with people that have actually written Vyper, let's look at some examples of what Vyper looks like. So this is always a nice example. It's just like a name registry. And you can see, so the top is the mapping type. We're mapping addresses to bytes. And you can see immediately it's constrained by 100 bytes. Then no modifiers, as I mentioned. So you can see the assert. I look up, is it a 0 address? If it's not, I set it. That's it. And then there's a lookup function where I just return the value out as an address. So yeah, I think pretty straightforward. Yeah. And yeah, also I said the public decorators. You can see that they're forced. And this is something that evolved out of. This used to be a feature that was just like it had a list of static units, and then someone suggested, okay, that doesn't make sense because you can never cover all unit types. So let's just make it that you can put a custom unit type in, and we take in the built-in units. And I think this is a really nice a touch because like you can this is like a simple example of using the unit system. But what it allows you to do is like if you're working with one set of decimal values or one set of integer values, you know you can never like sort of poison them. So if you say I need an output of velocity and it's meters per second, I can now not go and then accidentally add another constant that now I would actually change the unit type and there will actually be a wrong formula because the unit system is enforced. So yeah, a nice little added thing that you wouldn't find in Python. Right, this is a more complex example. What I wanted to show is that there's a shortcut you can put at the top for the defined, you just wrap it with public, and that will create a public function to access, in that case, the address list. Basically, this is a very simple, like a multi-sig contract, but you would retrieve or approve a transaction in one shot by collecting a bunch of signatures. So there's obviously a lot, like this is, as you can see, please don't use this yourself, but it's just nice, it's a nice example of like what the language looks like. You can see it's, I don't think I mentioned it, but you can see it quite clearly. We started off saying, oh, well, we can go with dynamic type, right? Python is a dynamic type language. But then what we realized as feedback from the community came in, it wasn't always clear, like, is this a bytes type? What size is this bytes type? Oh, this is now an integer, this is now a uint. How do they pollinate together? And in the end, it boiled down to like, you need a static type language to make it very, very explicit about what are you reading. Like, what can I actually do with this variable? Because it becomes it's very unclear if you like start, oh, this is a string, I set it to a variable, but then I suddenly add one to it, right? So, yeah, and this way it's very clear to see what is every specific type, and it's also very clear like what's my signature of my function and how it comes in. So yeah, you can see we had a long discussion at some point about concat. I had this idea like, okay, Python, you can just this is the nice thing about talking about languages. There's like a lot of opinions, and you kind of have to converge in a decision. And concat is one of them. Well, I proposed, okay, let's use the plus symbol. And then when you do the research, you see like a lot of languages do have actually different operators for concatenating strings and so forth. And then you realize, okay, but there could be like at least a very large population of programmers or people that will read this, and they won't know that the plus symbol will actually mean, oh, we're concatenating two strings, and then we just left it as a concat function. So every time we make a decision, it's like you always have to go research and think about how someone would read the contract. So basically, what happens here is you get the data of the transaction you want to execute. Then you convert it all to these 32-byte chunks. You concatenate them into a hash of it. You take the hash, When you add it, I think you all are familiar that obviously we have to add more data to our messages that we sign in the client, because it could be a security risk as you could sign a transaction. Then the sequence is just announced that someone can't replay your transaction once they've seen it. And then, yeah, there you go. You just loop through the signature information, and then you do an EC recover, and you count the number of approvals that you set in the init, and then you just do a raw call. Raw call is like more of a raw call is more of a built lower level function, and I will show you the cleaner interface on the next slide. You can see we have like a fallback function default, and you have to specify that it's either payable or not payable to say if you may or may not receive funds on the contract. Right. Yeah, okay, so there's a slide missing from this version, but this is the offline version, so it's fine. So the next I just wanted to talk a bit about how we evolved a bit, and then there's actually a lot of tools already out there for using Vyper, and coming from when I started on the project, where I think there wasn't even a Vim, not even one highlighter, and we've evolved a lot, and I've recently started work on a debugger that I want to make as friendly as possible, and it's on the next slide. So you can see the So the idea is that if you're familiar with the Python debugger, is that you can use it in the same way, and just see your locals, your globals, and read out. And then they have a lot of other ideas to expand it, but this is how far I've gotten with. For the other people that they hook their own conf tests in and so forth, I'll make it easy that you can just plug it into your tests as well when you want to break and see what the state is of the EVM and so forth. You can see I'm still working on it because the to-dos and so. Right. And then you can, this is the test source code and it's part. Right. Whoops. That went skew. So beginning of this month, we tagged the first beta, and basically what this means is we try and limit the amount of further syntax changes. And for those that have been using Vyper, they know that there've been a few, just a few alterations. And so this is kind of what I have in mind, is we freeze it at this version, and we keep it, I like the current state of it. It's very simplistic in the sense that we don't have to worry about too much, but we can still get stuff done. And it's in my opinion, now we just start printing out the bugs, and then we can say it's a final, and then I believe the runtime verification team has started again. I think it was last week that they came online on Git again, and they started running tests again against the current master. And so that's kind of what I'm working on next. And then just to mention about EWASM. So how I see this playing out is there is no incentive to, initially, if we do go the route of using WASM as a and I think it's kind of clear that this is where we want to go, but let's say, initially we can just use a tool that converts the Vyper code or the Solidity code that's EVM1, and then converts it to WASM, and it will run, and it will be cool. But the problem is there's no incentive in terms of gas to run this 256-bit processor on another 64-bit processor. You're just going to, at minimum, you're going to pay always 4 times the amount of work. So what I see happening is that Solidity and Vyper are going to say, okay, well, we introduce these new types, or a new, a flag on the compiler that uses only 64-bit types. In memory, we have 64-bit chunks, and so the alignment and so forth. So that's what I see what's happening, and what will happen, because if we don't do it eventually someone's going to like just start another language and then just make everything 64 bits, basically. Yeah, just to give you an idea, like this is the amount of work that goes into implementing. Okay, like it's not fair because like what this also does is like maintain its own stack because like Wagener doesn't have a stack, so like that's some of the work at the top there. But it's very clear that you have to do a lot of work, and I know with the Nimbus team as well, like they had a lot of fun implementing unit 256 math in the VM, and that's the thing, right? So like there's no reason to do all this translation in the long run, and so that's why I see a Vyper 64 evolving into Vyper 64. And then I thought a bit further on it, and I was like, well, obviously we're going to need a new API version, because otherwise you're just going to end up sending these empty strings eventually. And we'll probably have to evolve on how the API probably gets tighter packed into 64-bit chunks, like a new version. And I think it's anyway a very good idea to have some sort of version on the API as well. And having a version on the API is something I think we should do anyway. So this would be a good opportunity to do so. And yeah, just a shout out, come drop by the GitHub, come try and install Vyper. See, yeah, just check it out. Any type of feedback is really appreciated. And thanks for using Vyper for those that already are. Yeah, sure.
Thank you for your talk. I guess I have 3 questions. So first one would be, if a function doesn't return, does it have an implicit return value such as none, as in Python?
Okay, so you annotate a return type.
Because I saw it wasn't annotated on these functions that did not return. But
right, then the signature says it doesn't return. So basically like you'll just get an empty return.
Yeah. But is the annotation for such a function optional? Can I annotate that it does not return?
Yes.
Oh, okay.
Well, you can't. Well, that's a good question. We could add that you have to specify none.
Yeah.
But at this case, in its current state, it's implicit. If you don't annotate a return type.
Yeah. Because we use MyPy for instance in PyVM. And they are like the stricter checks just want you to also annotate the none cases.
Sure, I think that could be a good addition.
Yeah. Second question would be, are there any plans to support generics? And is this something that you would consider useful?
So, to be honest with you, I've not considered it at all.
Okay.
Yeah. Yeah, like...
It's something that increases type safety, obviously, so... That's
right,
generally a good thing.
The way I see it is like what you're going to use it for in a contract, right? So that's how I see about it. Mm-hmm. That's a really complex thing for a contract.
Yeah.
So that would be my immediate thoughts on it. But
yeah. Okay. It's got to be use case driven. Yeah. So well, it would be interesting to think about. And another thing regarding the disallowed dynamic types. How exactly would it be handled? Like if you have a token and you don't have a upper limit on balances,
So the only structure that can go infinite are map types.
Map types can go infinite.
Yes.
Oh, okay. Gotcha. Okay.
Yeah, so that's your only infinite structure, map types. Yeah.
Sorry, just back on the topic of typing for a second.
Sure.
Is it strictly typed, or is there some type inference happening? I may have missed that.
Yeah, it's like I don't know. Yeah, it's strict.
It's strict.
It's strict, yeah.
Okay.
Yeah, that's why you'll see everything is annotated.
Cool. And then, sorry, just one more quick thing on the EWASM topic. Why not be future compatible and add the sort of I32 and 64 types now? Like, are you waiting for something?
Yeah, sure. I'm still exploring the space. But that's definitely the plan. Is like, but I do envision that it's probably going to be like I'm going to have Vyper and Vyper 64, and Vyper 64 is going to be a Vyper 64-bit specific program.
Just to iterate on the type inference part. So does it have inference of types, so that...
No, everything is strict.
Okay.
So any type of assignment, you must specify what it is.
Okay, okay. Gotcha.
So there's no like a var statement or anything like that.
Okay, great.
I realize that I've used the constant decorator a ton, and I actually don't know if does the compiler enforce that?
No. the constant decorator. Yeah, no, that works. Sorry.
Okay.
I thought you
So if I tried to write in a
Yeah,
constant, it would throw an error.
Yes.
I guess I just haven't
Yes.
tried it.
And there's also a nice thing that was now, of course, in the online slide and not the offline slide, is if we use when we specify an interface for interfacing with an external contract, we have the keywords constant and modify. So when you actually use this interface to call, it would actually switch between a static call and an actual call. So there's like this extra enforcement of like, am I changing state or am I not changing state that you can specify on the interface, which is, I think, is quite important.
Wait, so there's an interface so that a constant function can actually do a call?
So there's if you're doing an external, like so internally, they are all it's enforced by the compiler because you have the function there, so you can check, am I changing state, right? And then for an external contract, we can also specify which type of call you can make to that contract. So like I said, just another level of enforcement.
All right, I have two questions.
Right.
What happened to the funny snake in the logo competition?
The funny snake. The one with the hat, or the one without the hat. I think that one got like 7 votes, but then there was like this. This was this really like this is the thing, right? It was like a 2-man decision about posting this logo bounty, and I was very scared because like we all know what happened to a certain boat naming competition. So. But it went pretty well. There were 2 logos, so when we ended up, we split into the 2 top logos. We split the bounty between the 2, and then we selected this one. So.
Cool. Second question. You talked a little bit about decimal. How does that compile down to operations in the EVM?
So we just, because it's so large, we have such a large register basically, we just like have a fixed divisor, so it's only 10 decimal places, and we just shift it over. So it's actually just one big int, right? So.
Okay.
Yeah. Okay, nice.
Does there exist or are there plans for something like a Solidity to Vyper transpiler to help adoption?
There's actually a ticket for this. It was created like 6 months ago. But then when you start looking at how different the languages are, I don't think it's possible.
Okay.
Yeah, like you could get away with like cheating a bit and like just starting to like when there's inheritance you just like copy it over and stuff like that. But I think it's like 2 different things. Right? And like like a lot of if you look at a lot of Solidity projects, they have all these extra checks in, right? And you're gonna like if you start converting it, you're gonna like do these checks twice.
Yeah.
So like the better option is just to start new.
All right.
Are there some benchmark of the gas used by Solidity contract versus Vyper contract?
I'm smiling because I don't want to do it. Because it's going to be higher for obvious reasons, because of all these the clamps and the checks. But no, there's no benchmarks, but we can do that. Yeah.
I will point out for many use cases in practice, it's not much higher, because when I've done Vyper like gas optimization, like in practice, the gas cost one or high tends to be because of STOR, and I work with a pretty negligible compared to STORs, which are like 5,000 each.
Yeah. There's another suggestion, which I don't want to put in this version, but like got a lot of debate, which it's always nice to read some debate on the internet, right? So the thing that we do that I like in Vyper is that when we go between function calls, we use the call statement. So this is really cool because we know the whole VM is cleared and there's no possibility that someone can like somehow eventually manipulate the stuff. Especially in Solidity, once again, because they have inline assembler. So there's a suggestion that for internal calls at least, we start using more of the jump opcode to save on gas. But I'm not very keen on doing it in, like I said, in the beta release because this is kind of like, I like it how it is and I wanna like make it solid in the way. So.
And to be fair, if you're doing, if you're comparing Solidity to Vyper, you should probably use Solidity with safe math.
Yeah, probably, yeah.
Or at least have that in the mix.
Yes.
What, in your opinion, needs to happen, and the timeline on that for you to start comfortably telling people like you can use this in production?
Right, I don't know, man. So I'm very confident in what the formal verification that's been happening throughout the process. Because if you've seen some of these bugs that they detect, it's like amazing. Like never had this experience before. I think that they even over 15 bugs. So they're doing like another round now, and I think after that I will be fairly confident.
You're recording this.
I know it's so bad.
And you have a timeline on that?
No, well, it depends on the verification.
Just the answer to the previous question got me thinking. So you said that currently in Vyper, the calls between the functions are done by a call instruction, right? Not by jumps.
Yes.
Okay, so that made me think of there was an AIP some time ago from Greg Colvin, which was proposing to remove the dynamic jumps from EVM.
Right.
And replace them with only static jumps, because at the moment you can jump to whatever is on the top of the stack, right? And he said that that would allow you to do linear time, some kind of static analysis.
Yeah.
So the question is, do you think, so do you actually have any dynamic jumps when you compile?
No, I don't think so.
Okay, so it might be statically analyzable, right?
Yes.
Oh, okay, so that might be the reason to keep it that way.
Yes, exactly. And like I said, I'm not very keen on changing it.
And another thing, it's just a comment, I actually made the same comment in Toronto in the Vyper talk, is that when you're comparing the gas usage between Solidity and Vyper, something which I noticed when I was digging really deep into the bytecode, which is generated. So the way that the bytecode is generated for arrays and for, I'm not sure about mappings. So you know that Solidity, for example, does some hashing to derive the actual storage address of the variable, and it does it a different way for mappings and for the hashes, for the arrays. And I have noticed that on one occasion, I think when you represent arrays in Vyper, they so the entries in the array, they actually occupy contiguous storage indices rather than in Solidity they're spread across the storage. And also there is a different cost in terms of how many hashes you perform. So I think in Solidity you end up performing more hashes to store the elements in the array. So that might be something to factor in when you do the. It might be in some benchmarks actually the Vyper compilation will be more gas efficient.
Yeah. So I think once we've, like I said, like this will probably be something that I clearly get now is like maybe we should start doing gas comparisons. It's just like we've kind of just been focusing on like making it secure and like everybody knows like you would rather pay even double to triple the amount of gas to just know, hey, I can't overflow this function. So yeah, that's kind of been our focus. Any other questions?
I think that you should run a Vyper gas competition.
That would be cool. That would be really cool.
You can use the same requirements and see what people get at.
Yeah,
I think that ended yesterday.
Okay, so that's ready for the next one.
Or today. Yeah. So now it's time to start.
Sounds good. Sounds good. But on the same note, though, like I feel like it might be a lot more difficult to do this in Vyper because like we don't have inline assembly or anything like that. So.
Well, there's the
Okay. Okay, that's cool.
But there's also more Solidity experts working on that, so.
Yeah. Sounds good. Maybe put a tiny bounty on this too. Like.
So Solidity is kind of trying to move to compile into the intermediate language YOL instead of directly to EVM bytecode. Do you have any plans of integrating that as well?
Just so I understand, they're using a new IR, like a new intermediate language?
Yeah, not yet, but that's the plan.
Yeah, so this would be great. I'm a big fan of Triple L, and I would rather like let us standardize on a one LLL, and then go on with that. But yes, if we're going to go in the direction of WAS, then this is something we could definitely consider using the same line.